In this video, we're discuss drawing arrays with mirrors and lenses. I actually prefer just using the equations, but drawing arrays is just another alternative way of solving it, and it's a good check. If you finish your exam and you can have your answers, and you're quite exactly sure, just draw some rays and check your answers. One thing to remember is that mirrors is a little different procedure than lenses, and also it's important always to remember the sign conventions on whether a focal length is positive or negative, because that's critical to draw your rays right. So we'll start with mirrors. So here's a convex mirror. It has it has a positive radius of curvature. So therefore, if I have an object, so let's say the left side is a reflective side. If an object really on the left, if I see a real image, I expect to see the real image also on the left. So therefore, my radius, my focal point, my focal length is positive. My focal point here is at that focal length from the surface. And for mirrors, when we're drawing rays, we always have to be concerned about the center of curvature. And the center of curvature is the radius of curvature is twice the focal length, or you can say the focal length is half the radius of curvature. So for any time you do mirrors, you're going to draw the focal length in the correct spot, and then you're going to draw in the center of curvature is actually going to help you to know that, because here's my curved surface, and there obviously my center of curvature is there, so that helps remember my focal length is on that side as well. So for mirrors, we were about center of curvature. Actually, when you're doing the lenses, you don't worry about center of curvature. We'll talk about that when we get there. So we're going to draw the mirror. We're going to put the center of curvature and the focal point. So there's our first two starting spots. And here's my object. And now there's two rays that are, you can draw more than two rays, but two rays tell the whole story. So the first thing you do is you draw with a mirror. You draw a ray from the top of the object. Just keep going it and go through that center of curvature, and just have that ray just keep going. So now this is my one line, and I know my top of my image is somewhere on that line. Now the second thing we're going to take advantage of, we know that if a ray is coming in perpendicular to the surface of this, the ray is coming in perpendicular to the surface of the mirror, it's going to reflect off and go through the focal point. So I'm going to draw one from that array that goes through the top of the object, hits the surface, hits the mirror, and then it's going to reflect off and go through the focal point. So I'm worried about this. I'm worried about this part after deflection. That's the part of ray that I'm concerned about. So I'm going to keep drawing that, and somewhere this first line, that first ray line, draw, and that second line after it impacted, I don't worry about the part before it hit, but once it comes to the mirror and comes off, somewhere this line and this line will intersect, and you can see that happens right here. Well, that's where the image will be, and you can see that the image is in between here, the focal length and the center of curvature, and it's upside down, which means it's going to be a real image, and so that's how we solve that case. Now look at our concave mirror here. So here's my reflective surface on the left side. Here's my curvature. There's my circle. So again, I know my center of curvature is here. My focal point is half the radius of curvature, and recall, for a concave mirror, the focal length is negative, so this all makes sense. It's on the wrong side of the mirror. So now I've drawn for my mirror the focal point and a center of curvature, and I'm going to draw my two rays. Again, the first ray is going to go from the top of the object and just going to keep projecting through. Even if it's on the back side of the mirror, I'm going to go through that center of curvature, and that's my first line. So I know my answer is somewhere on that first ray line. The second one, I'm going to again draw perpendicular to the surface of the mirror, and then I go through the focal point. Remember, the focal point is halfway between the surface of the mirror and the center of curvature. So I'm going to draw that, and so I know my answer is somewhere at the intersection of this first ray and the second ray, and you can see they intersect right here. So you can see my image is inside the focal length this time. It's upright, so therefore it's virtual, and so that's how I draw rays for mirrors. Now for lenses, I'm going to draw my first ray differently. I don't worry about a center of curvature. The first ray is going to go from the object, and it's going to go, the point we pass through is the center point. So in the center line of the lens along with the center axis, so the perpendicular, that's where the point where the first ray goes through. So I'm going to have my object right here, and I'm just going to draw a line that connects the top of that object through the center point of the lens. Now the second part of this is the more critical to understand. So that first line is always going to be drawn, whether it's divergent, convergent. That first ray is going from the top of my object through the center point. So that's the consistent way for a lens, I'm going to draw that first one. So it goes to the center of the lens. Remember back, and for mirrors, we're going through the center of curvature of the mirror. So all these four cases, you can see I drew that first ray going through the center of the lens. Now here's the part you must remember for whether or not the focal length is positive or negative. So if I have a convergent lens, for a lens, if I have an object on one side, I would expect, if I see a real image, to be on the opposite side. So therefore, if I have a positive focal length, I expect it to be on this side where I'm going to have this true image, this real image. So therefore, this is the focal point that I'm going to use. So even though a lens, if rays are coming this way, they would converge to this one. I don't want to worry about drawing rays to this point, this focal point on this side. I want to draw it to the true focal point. So for convergent lens, that's the focal point. So the focal length is positive. Yeah, so this is a positive focal length is this side, because that's convergent. So that's the one I'm going to draw through. So again, we're going to take advantage of if I have a ray coming in perpendicular to this lens, and it's from infinite, it's like infinitely coming out. Well, we know it's going to refract off and go through the focal point. So I'm going to draw this one here and right there, okay? And so then I know that somewhere on this line or its projection of it will be the intersection point. Well, I mean, on this side, these lines are diverging. So, but if I project that line back right here, you can see that there was, between this first ray and that second ray, there's my intersection point. So my image is there. It's on the incoming side. It's upright, and so therefore it's virtual. Now look, here's another case where a convergent one. We drew here's my object. I drew my first ray. That's a simple one to draw. I know the answer somewhere on that ray. The second ray, I'm going to draw perpendicular to that surface. I must again go through the focal point, and here you can see that I get an intersection of those two lines here, and so my image is upside down, and it's real. Okay, and it's in the positive image distance. Divergent lenses, focal length is minus. So that means that if I have an object on this side, the positive focal length would be over here, a negative focal length is over here on the same side. So I know f is less than 0. Okay, so that's the one I'm going to draw the second ray perpendicular to the lens, and then I have to have that ray go through this focal point. So we know, so I have a line here, and I have my first line where they intersect is right here. So I can see there's my image that's going to be upright, therefore virtual, and it in between you see the magnification factor is less than 1. It's on the focal length. Here I drew a case where the object is outside the focal length for this divergent lens. Again, I do my first ray, my second ray, perpendicular, then going back through the focal, so I know the answer is somewhere between these two lines where they can cross. You can see it actually happens right there. The image again is upright, so it's virtual, and once again it's between the mirror and the focal point. So that's how one can quickly draw rays and check their answers.